Now, I know this is quite a tough pill to swallow because we just covered 4 formulas that seem to say the same thing. So let's summarize things a little bit. So there are 4 cases that we've really studied. One was Laplace transforms of jumps. Transforms of jumps. That's where we did the Laplace transform of a shift and jump. So for instance, Laplace transform of t minus 2 cubed, u2 of t. So once again, we have a shift and a jump. And the main thing that we learned is that an exponential term appears. So this becomes e of minus 2s times the unshifted Laplace transform. So L of t cubed, and which is just e of minus 2s of 6 over s to the 4th. So if you have a shift and jump, an exponential term appears. The second case was the reverse way. So if an exponential term is outside, then what we get is a shift and jump. So for instance, if you have, let's say, e of minus 5s, and then Laplace transform of t cubed, and you want to put it inside, that's when you do a shift and a jump. So this becomes Laplace transform of t minus 5 cubed, and then u5 of t. That's sort of what we did in the last lecture. And in this lecture, what we did, we first saw what happens if the exponential term is inside. So case 3. Term inside. That's when you just had a shift. So for instance, if we have Laplace transform of e of 3t cosine 2t, well, the Laplace transform, remember, of cosine 2t is simply s over s squared plus 4. And if the exponential term is inside, you shift all this. So s minus 3 over s minus 3 squared plus 4. And in the reverse way, again, just reading the formula from right to left, if a Laplace term is shifted, then you add an exponential term. Sure. So for instance, if you see the Laplace transform of s minus 2 squared plus 1, that is, I believe, the Laplace transform of sine shifted by 1 unit. So it's kind of 1 over s squared plus 1, which is the Laplace transform of sine of t, and then shifted by 2 units by 2. And you would say, okay, because there's a shift by 2 units, we add the exponential term. So L of e of 2t. And then sine of t. So once again, a bit convoluted, but there are 4 cases. Shift and jump, exponential term comes out. Exponential term outside, you shift and jump. Exponential term inside, you shift. And if you see a shifted transform, you add an exponential term depending on how many units you shifted by.